Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Today, we're going to take a look at how to fix the rubber keypads that are used on remotes. And the same type of conductive rubber is even used on the key plungers for Amigas and Commodore 64s and lots of other computers. This is kind of a summation of experience I've had over the years of working on these types of things, and I wanted to put it all together in one video as a reference to maybe that'll be helpful to other people when they're trying to repair these types of things. So let's jump in and get started. We'll start off here by looking at a Mitsumi keyboard plunger, which this particular one is from an Amiga, but they are similar on the VIC-20s and Commodore 64s. What we have here is the key plunger from the main return key on my Amiga 500 keyboard. You can remember this was bad when I first got it. As it turns out, every key on that Amiga keyboard, which was new in box, it had never been used, every key that was a large key that had the wire bail underneath to help balance it out, those wire bails were lubricated with some grease right where they pivot, and some of that grease got down and contaminated the rubber here on these key stems. Every one of them went bad. A very kind viewer sent me a few good ones, so I was able to swap one good one in and swap some others with the numeric keypad to the side, which I don't have to use in order to use the machine. So now we're going to investigate what we might be able to do to fix these. I made a little fixture here, which is just a machined out circuit board with pads where the contacts are on this guy. So I have a pad here and a pad here. I'm measuring that with my meter here. And doing this, it's a little overly complicated, but it does give us nice repeatable measurements. So I can stick that in there, and I'll get 100 k ohms, and still about 100 k ohms. So this is, notice the k ohm here on the side. If I compare that with a good one, this is 300 ohms. In case you're curious, this is what the Mitsumi Amiga key plunger test rig looks like. This is just a little circuit board I milled out. It's single-sided circuit board material. This is where these contacts here are where the plunger meets. These two contacts here, I was trying to see if I could measure the resistance just across the pad itself, but that didn't work out very well. And this is just a little 3D printed case. A little slot here for the wires to go through. And ow, it's tight. That snaps in there like that with some screws. And you have a test rig. That worked out really well. A few videos ago, I tried to apply some conductive paint to this surface, which didn't stick, of course. And this is quite thick, probably close to 2 millimeters thick down here. And these little ends are kind of ribbed. I had one suggestion from a viewer to try sanding these contact areas. I saw that same suggestion in a recent Adrian Black video. And I was reading a back issue, well, I guess they're all back issues now, of the Transactor. I think it was Volume 5, Issue 5, so it had been, into the early 80s, where they also talked about sanding the conductive rubber slightly. So we'll give that a try, and we'll remeasure it and see what kind of difference it makes. One of the suggestions I saw online said just to use paper, which of course will be slightly abrasive. So I'm going to press this down till the plastic is rubbing on the paper. Just rub that back and forth several times, and it does leave a black streak there on the paper. And I can't really tell. I'm looking under the magnifier here. Yeah, it looks like the surface of the pads is slightly dulled. Oops. Place it in the fixture there. And, well, that have the resistance. It's down to just over 50K now. So maybe we'll give that one more shot. Still about 50K. Yeah, with the paper, we're really not getting much below 50K. I'll try some fine sandpaper now and we'll see how that does. I've got some 400 grit sandpaper here. Just going to go over this a few times and measure. Still about 50K. Haven't quite sanded off the ridges on there yet. And we're not much better than 40K. We can't just coat the surface of these two pads here because the current has to flow all the way through this. I've got the key stem right here and some pointy probes. And if I measure the resistance across the pad itself, that is about 800 ohms. It's similar on both sides. So even on the surface, just a millimeter apart, there's 800 ohms resistance, which is too high. Flip that on its side. I measure across on the side of the pad, and that poking the probes into the rubber is about 2K. So it seems like the whole rubber is affected. So I think what I'll try to do is I'll cover the side of that C-shaped piece with the MG Chemicals conductive stuff and try to work it up over the surface, and maybe that'll be sufficient. I don't know. I don't know if it's possible to fix these. As you'll see, I had some issues when I first tried to use this MG Chemicals repair kit. In a few minutes in the section on the keypads, I go through what I did to figure out what that problem was and discovering the proper mixing time, etc. So keep watching. So, how did our experiment with the MG Chemicals kit work? Well, it was so brittle that it cracked right off of the Amiga plunger, which didn't make any difference because it wasn't very conductive at all. Even on this MakerBot keypad, you can see the coating right on there. This is measured about 0.5 megohm, so it's not very good at all. It actually made it worse. This may be because I didn't shake the graphite tin well enough to mix it up, although I did shake it for a few minutes. So what I'll try to do is to shake up the graphite pin for several minutes and put a coating down on a piece of plastic, let it dry overnight, and then measure the resistance and see how that works. Okay, here is another idea for the Amiga Mitsumi keyboards. This is a brand new C16 keyboard I bought a while back. The layout and wiring is a little different than a Commodore 64 VIC-20, but the design's pretty much the same. Same connector, that type of thing. So let's pull this apart and I'll show you what I mean. So this uses a piece of PCB material with some carbon on here rather than the membrane like the Amiga. Let's use our keycap puller. And we'll pull off just any old convenient key here. There we go. You can get these for a couple bucks on Amazon or eBay. Well worth the investment. Okay, now we have a key stem from the Commodore 64 / VIC-20 / C16. Let's compare this up close to the Amiga. Okay, here we have the C16 key stem on the left and the Amiga 500 on the right. These are both Mitsumi keyboards. And you can see that the black rubber part here, that's the part of the rubber that is infused with carbon, is kind of C-shaped or U-shaped or mustache-shaped, however you care to describe that. You can see those are just about the same width there. So what I'm thinking is, this is hard to do on camera. There we go. See, it's the way this is designed. You have the black silicone rubber is glued to this clear silicone rubber piece. And we'll take the one from the Amiga. See, it's similar, but they're not the same. So it wouldn't be a direct swap. If you were desperate, you might be able to cut the piece of rubber off of this one and off of this one and glue the one from the C64 onto the Amiga. I know that seems pretty extreme, but it seems like here in the US that the replacement or spare key stems are harder to get and fairly expensive. Even just the keyboard in unknown working condition can be $50–$60. And individual key stems with the keycap are around $10. So if you have 4 or 5 bad key stems, it can be kind of an expensive proposition to replace it. So if you're desperate and you can't get a hold of the Amiga ones, you might be able to make your own out of an old C64 keyboard. Now, on the Mitsumi type key plungers used on the Amigas and the Commodore 64s and VIC-20s and such, if these are just dirty, you can clean them. You can sand it lightly with some paper, and you stand a good shot at reviving it. If it's been contaminated with grease, like I've seen on the Amiga, and what I've heard from other people is that once they're contaminated, there's nothing you can do with them, and that's certainly been my experience. So you have to find a direct replacement and swap it out, or if you're really desperate, you can try transplanting one from a C64 to an Amiga, like we saw a few minutes ago. Now let's look at rubber keypads. These are the type of things you'll find on remotes and other small devices. The one we're going to look at here is from a MakerBot 2X 3D printer. This particular keypad is from a MakerBot Replicator 2X 3D printer. It's got 5 contacts here on the back. I'll see if I can zoom in. I don't know if I'll be able to show this to you. Maybe just. The black conductive rubber is just a thin coating on here. I tested the resistance of each pad, and it was close to 100K or a little more for each pad. I sanded this one down slightly, just enough so there was a dull finish compared to slightly shiny finish of these others, and it didn't change the resistance any, but you can see it wore off around the edge. And that black rubber doesn't stick up enough really to try to use one of the stick-on conductive disc. One of the things I had tried on this particular keypad in the past was using the conductive paint that's used to fix the automotive defroster grids. You can see a picture of that here, and while it's very conductive, it doesn't stick to the silicone rubber worth a hoot. So I'm going to try this. This has a surface conditioner to help it stick to the rubber. And then you put some super glue down, and then a conductive pin which has graphite in it. You let that set 24 hours, and you should have a conductive keypad once again. So we'll see how it works. Here I've laid things out roughly in the order I'll need to use them. We start with the primer pin, then the super glue, and then the graphite pin, and I've got some wax paper here to use to squirt the graphite onto, and a couple of the cotton swabs that comes with the kit. I've already cleaned this with, drop the pin, I've already cleaned this with alcohol a few years ago. I'm going to shake up this prep pin. Makes a bit of a clicking sound, and it's really absorbed kind of quickly into the surface. Okay, we need to let that dry completely. This is official MG Chemicals super glue. Okay, that looks like it's fully evaporated. I'll open the super glue now. It says dispense the super glue onto the cotton swab. And then paint that over the surface. And we'll give this a few minutes to dry. Okay, it's been a couple of minutes and our super glue is fully dried. And I've been shaking this graphite applicator pin. Okay, and it says to apply the graphite to a slick surface. So I'm going to use this piece of waxed paper. There was a bit of fuzz there. There we go. Okay. And use a new applicator to apply a very thin coat to the surface. Well, problem is I can't tell how that's working. Okay, that one I could see a little better. Graphite gets absorbed into the applicator pretty readily, it seems like. Okay, this is going to be very difficult to see on the camera, but the surface turns from black to gray as it dries, so you can tell you've got it on there. It's just very difficult to tell to start with. Okay, so now we've got a conductive coating on here. It says to wait 24 hours. We'll come back and measure the conductance tomorrow. Let's see what happens. And here is where I ran into a problem with this MG Chemicals kit. After letting this keypad set for 24 hours, I measured the resistance, and it was like 0.5 megohm across the pad, which was a lot worse. And I suspected this probably had to do with not shaking up the graphite pin adequately. So I set about to do some tests shaking it for different periods of time, applying some to a surface, and then testing the conduction, and even going to the extreme to shake it up. Let's see how that went. In order to test if shaking the graphite pin further would aid in it mixing and being more conductive, I applied some after shaking it in different amounts to this scrap piece of circuit board material. I did it after the initial 5 minutes of shaking that I'd done on my first test with the MakerBot keypad, and another 5 minutes by hand. I believe this one was another 10 minutes after that by hand, so 20 minutes total. And then I did the super mix, where I hooked up a CNC controller and wrote a short piece of G-code to basically just spin the tube back and forth, which you can see here. And found out that I must have got a package that set around a little bit, and it took 10 or 15 minutes of shaking to get it mixed up enough, so it worked quite well. Here is our MakerBot 2X keypad. Now this isn't the one that I showed you before. This is a second one. The first one, I reapplied the coating after shaking up the graphite pinwheel, and it worked great. And on this one, I did this a couple days ago. And if I check resistance like so, get 300 to 400 ohms up to 1K. It depends on how you touch it. You don't want to poke on that too hard. Now, on the first one I did, I installed that back on the 3D printer, and it works really well. It's got a good feel to it. It's not hard to press or touchy or anything like that. So I think the trick to using this stuff is to make sure you shake it up well. I noticed that when it's well shaken, when you get some of the graphite mixture out of the pin, it has a very distinct wet paint type odor to it, whereas the first time I tried it, it didn't. On the first keypad, the one that wasn't very conductive when I first did it, I thought about scraping off the graphite coating, and I flicked at it pretty good with my fingernail and then a flat blade screwdriver, and it was on there quite well. So I just applied another coat over the top of it, and that worked fine. So the stuff seems to be pretty tough, and with all the other preparation chemicals that are included, it sticks well. The rubber keypads that are used on remotes and the MakerBot that we took a look at can be cleaned if they're not too bad, and the MG Chemicals kit actually did a really good job of repairing that once I figured out how to use it. I also found that when I did the second keypad, being more familiar with the application process made it a lot easier, and it was a lot faster, and I did a better job at it. So I would highly recommend that MG Chemicals product. Another option, if something like the MG Chemicals kit isn't available where you're at, is to get a set of replacement conductive rubber discs. You can get those from eBay and Amazon and such, and I'll show that right here. And if the rubber contact or the carbon peel on the back of the keypad is sufficiently thick, it needs to be about 0.5 millimeter, you can slice that off and use some silicone adhesive to glue a new conductive rubber disc on there. And of course that'll work quite nicely. It's just a little time consuming and fiddly. Of course, the conductive rubber key plungers and keypads wouldn't be of much use without something in contact with. So let's have a quick look at the circuit boards and membranes that they do touch. This is a C64 bread bin Mitsumi keyboard. You can see it uses a circuit board, not a membrane like the later computers did, like the Amiga. And it doesn't have the carbon contacts here like the later 64C keyboards do, or the Amiga membranes do. It has gold-plated contacts. So in these, if you mess up one of these gold-plated pads, that's a little harder to fix. You could try to use some conductive silver ink. If you have a broken trace, you can fix that like a broken trace on any other circuit board. This specimen is the PCB from a 64C Mitsumi keyboard, and you can see instead of the gold-plated contacts, it uses a carbon-covered contact. Now, if these carbon contacts happen to get damaged, you could use something like this conductive paint that didn't really work well in the key plungers itself, or a conductive graphite pin. This is the membrane from the Cambridge Z88 that we worked on a few months ago, and if you might recall, I just replaced it with a new membrane that are now available because the shift keys didn't work, and the shift keys, which are right here where my thumbs are, happen to be what turn it on. This type of membrane has conductive ink fingers that go like this and a set that go like this, and there's conductive pads on the keys. You can treat the conductive pads like you would the smaller conductive pads by lightly rubbing them on a piece of paper to clean them, that type of thing. If you have a break on the traces here, you can try using a conductive silver pin, that type of thing. You got to be careful though, because this is quite flexible and the conductive inks are not very flexible, so you want to take care not to bend it too much after you fix it, or you'll break your connection. The issue with this particular membrane is the conductive ink under the shift keys that are used to turn it on and off that ink actually wore down quite a bit. And that would be very difficult to try to fix by reapplying ink due to how finely spaced that grid is. Luckily, someone does make modern replacement membranes, though. Luckily, our keyboards that used a circuit board rather than the membrane are actually pretty robust and usually just need cleaning. And like we saw, if you have a broken trace or somebody was a little over aggressive with a carbon pad, that isn't too difficult to repair. Membranes can be repaired if it's something simple like a break in a trace. Finding it can be kind of difficult. If you've got a worn out conduction grid, though, that's another matter, but luckily there are people remaking these membranes today, and I think they're well worth the $25 or so a piece that you can pick them up for. Well, I hope you found this video useful. I know that I've tried many different things over the years trying to fix these types of rubber conductive keyboards and keypads, and I was glad I finally found a product, this MG Chemicals kit, that works for the disc type conductive rubber keypads. Now, that didn't work on these Mitsumi key plungers because of the shape and how they flex and the fact that the ones I had were contaminated, but it works great for other things like remotes and that MakerBot keypad that we had. The types of keyboards that use a circuit board rather than a membrane seem to be more robust, and they usually just need a good cleaning. The membranes tend to wear out, they're a little harder to fix, and sometimes you just have to buy a new replacement, but thankfully those are available now. Say, if you're a subscriber, thanks, I really appreciate it. That helps out a lot. If you're not, what the heck you waiting on? If you look down below, you'll see a rectangular subscribe button, and if you click on that guy, you'll be subscribed to the channel. And once you do that, you'll see a bell-shaped icon. Go ahead and click on that guy too, and YouTube will let you know when I post a new video. That way you won't miss it. If you have any comments or questions, just leave them in the comments section down below. I would love to hear from you. I'll also put a link to where I found this kit on Amazon down below. And if you would like to support the channel, I do have a Subscribestar account now, and of course that link will be down below in the description as well. Well, until next time, bye.